Hello students, welcome to Engineers. Deepak Pandey this side. We are going to discuss the last section of reaction engineering, that is heterogeneous reactions. Fine. So before this, every time we discussed about the homogeneous system of reaction where there was only one phase. Now either it was a gas phase reaction, or it was a liquid phase reaction, or it was aqueous phase reaction, but in all these three cases there is only one phase present. So what is so different about this heterogeneous reactions? The one thing which is different than that, in heterogeneous reactions more than one phase is present. That is the first thing, the basic thing which is different than the previous case. In heterogeneous reactions more than one phase is present. In heterogeneous reactions more than one phase is present. Okay, more than one phase is present. That is the one thing, right? So definitely we are not going to deal with the gas phase reaction because all the gases are miscible and they are considered as a homogeneous mixture, single phase mixture. तो उनके बारे में बातें नहीं करेंगे. We are not going to deal with the liquid phase as well as the aqueous phase reaction here. Here there will be more than one phase. And if you talk about heterogeneous reaction, there are two categories basically, the catalytic reactions and the non-catalytic reactions. In heterogeneous reaction, we have the catalytic as well as non-catalytic reaction. Non-catalytic but heterogeneous. An example, non-catalytic and catalytic. So non-catalytic means it's not a catalyst. There is no catalyst here, but definitely more than one phases are involved. Any example you can give here? The very basic example I am taking for non-catalytic reaction but heterogeneous is this. Carbon solid reacts with oxygen gas to give carbon dioxide gas. Now what do you think? How many phases are present here? In this case, gas and gas can be considered as a single phase while the solid has to be considered as a different phase. I hope you know that all the solid phases, suppose one type of solid and other type of solid, they can never be considered as a single phase. Suppose I have calcium oxide and I have calcium carbonate, both of them are solid, but they have to be considered as two different phases. So if I consider this example, there is no catalyst involved here, fine, but there is a solid phase and there is a gas phase. So we have non-catalytic reactions, right? Now this non-catalytic reactions are not discussed in GATE syllabus, fine. So you can write here that this is not our focus. This is not our focus for discussion in GATE syllabus. Don't compare the syllabus that we are going to discuss here in heterogeneous with that you have studied in semesters, because in some colleges this section is called CRE 2 and there is an entire semester devoted to this section. अब आप 2 नंबर के लिए पूरा semester devote नहीं करेंगे. So we have a very limited discussion here in heterogeneous reactions. Fine. So do not compare the things like that. Right? Because in our colleges also in our course also we were having CRE 1 and CRE 2. This is called actually CRE 2. Before that, everything was included in CRE 1. So we had an entire semester dedicated to the heterogeneous reaction, but here we'll be having hardly 4-5 hours dedicated to heterogeneous reaction. That is sufficient. Okay. So non-catalytic reactions, heterogeneous reactions will not be discussed in this our course. Okay. Now the next is catalytic reactions. I hope all of you know that most of the catalysts we have in the industries, which are used in the experiments, all those catalysts, most of the catalysts are present in solids form only, right? So there are some catalysts in gas form also, there are some catalysts in liquid form also, but most of the catalysts you hear about are present in solid forms only. Most of the catalysts we know are present in solid form only. And if it is present in solid form, then the reaction has to be heterogeneous. Getting my point? Because suppose if there is a solid and even if the catalyst is solid and even all the other reactants and products are in gas phase, still it is heterogeneous. because solid and gas, they can never be considered as a single phase. If the catalyst is in solid form, the reactant is in solid form, the product is also in solid form, of course they are going to be considered as three different phases. So again, heterogeneous. It means that all the catalytic reactions, because I'm saying most of the catalysts we know are present in solid form, hence most of the catalytic reactions, hence most of course there will be some exceptions, we are not going to discuss them. Most of the catalytic reactions can be considered as heterogeneous reactions. Most of the catalytic reactions can be considered as heterogeneous reactions. Okay, can be considered as heterogeneous reactions. Fine, heterogeneous reactions. That is one point. That all the catalytic reactions, almost all, because the catalysts are present in solid form, or agar catalyst solid form mein present hai, then definitely I can consider all the almost most of the heterogeneous reaction as a most of the catalytic reaction as a heterogeneous reaction. And in our course, we are not going to discuss the non-catalytic part. We will only discuss the catalytic reactions which are considered to be heterogeneous reaction. That is the first point that we wanted to that I wanted to convey to you. Right now, the third point. What were the units of rate that we have studied before this? I mean, in homogeneous system, as I was discussing during the earlier classes, that a rate is always having the dimensions of mole, having the units of mole by volume of the reaction mixture by time, right? Whatever be the order, whatever was the case, the rate was always having the unit of mole per liter per second, kilomole per meter cube per hour, like that, right? So but that was only for homogeneous reactions. So you can write here, for homogeneous reactions, we defined rate as, what was the way of defining rate for homogeneous reaction? That was minus RA, of course A is the reactant, was equal to, I'm not writing the formula, I'm just writing the unit, so don't worry, mole of A divided by volume of reaction mixture. This was the way of defining rate in case of homogeneous reaction system. And that is why in case of homogeneous reaction system, the value of the units of rate were always mole of A by time. So that was 1 by V dNA by dt, where V was the volume of reaction mixture. So this was the way we defined the value of the units and the dimensions of rate in case of homogeneous reaction. But now we have entered the heterogeneous section, and मैंने आपको पहले भी बताया था, when you are going to enter the heterogeneous section, the way we denote rate, the units of rate are going to change. So here we will be using different varieties, different values of rate, units of rate, right? So you can write down now that for heterogeneous reactions, following notations can be used. For heterogeneous reactions, following notations can be used, right? Following notations can be used. For heterogeneous reactions, following notations can be used. Okay, notations can be used. What are those notations? The first way of denoting the rate is minus RA dash. Why dash? Just to let us know that this is not the same way we denoted rate in case of homogeneous. ये homogeneous वाले definition से थोड़ा अलग है. Now how to write minus RA dash? What is the meaning of minus RA dash? It is mole of A reacted. This is also mole of A reacted. Okay, mole of A reacted. I have not written however here, so you can understand that this is always mole of A reacted. Now in the previous case we were taking volume of reaction mixture. Here instead of taking volume of reaction mixture, you have to take mass of solid. And what is solid? Means mass of the catalyst. So mole of A reacted divided by mass of the catalyst or the solid, mass of the catalyst, or you can say solid, per unit time. This is one way of defining rates in case of heterogeneous reaction, means it is equal to minus RA, okay, there should be negative sign here, right, because we are dealing with the reactants, right, so negative sign. Similarly, minus RA dash is equal to minus 1 by W. Now W denotes the mass of catalyst or the mass of solids present inside the reactor, dNA by dt. Another way of denoting the rate, which is also quite common in heterogeneous rate, there are various other ways also. RA dash, RA double dash, RA triple dash. We are not going to discuss all. We are going to discuss only those which are used more frequently in GATE exam, right, and more frequently in reaction engineering also. So the one is minus RA double dash. It is defined as mole of A reacted divided by the surface area, and with surface area, the interfacial surface. Mole of A reacted divided by the interfacial surface provided by the catalyst. Who is providing the surface in this catalytic reaction? The catalyst is going to provide the surface. So the interfacial surface provided by the catalyst per unit time. Fine. Now it is hence denoted as minus 1 by S. S denotes the surface area, the interfacial surface area, dNA by dt. Fine. These are the two ways that will be used most frequently in the discussion of heterogeneous catalysis. Now, suppose you are dealing with an nth order reaction, then how you write the things? For an nth order reaction, for a nth order reaction, for an nth order reaction, suppose I want to denote minus RA. How we denote this? Minus RA is equal to KCA, that we denote it like this, KCA raised to the power n, nth order, okay. Fine. Now suppose if I am denoting the rate by using another definition, so I am going to write minus RA dash is equal to K CA N, but this K and this K are not going to be the same, because what is the value of the units of K are going to be different again. So to differentiate between this K and this K, again here also I'll be using K dash, just to differentiate that this K is not same as the K I have used before. Similarly, minus RA double dash should be written as K double dash CA raised to the power N. Fine. So if I ask you that what is the relation between minus RA dash and minus RA double dash, you see this equation. Minus RA dash or minus RA is equal to minus 1 by V dNA by dt. Minus RA dash is equal to minus 1 by W dNA by dt, and minus RA double dash is equal to minus 1 by S dNA by dt. You can see that dNA by dt is common everywhere. So I can make a relation here, and this relation can be asked as a simple question in GATE exam. So please remember this one. This says that minus RA into V minus RA into V minus RA into V, which becomes dNA by dt, should be equal to minus RA dash multiplied by W. Let me use the dash inside the bracket. Minus RA dash multiplied by the W is equal to minus RA double dash multiplied by S. So that is the relation, and similarly you can also relate K dash and K double dash of these different ways of expressing the rates in case of a heterogeneous reaction. Fine. So first of all, you should have this idea very much clear in your mind that now we are not going to have only mole per liter per second as the unit of rate of a reaction, right? The rate may have a different unit, that is mole per meter square per second, or it may have the units of mole per kg per second, like that. These kind of units may be there. Okay, so now it is clear that in this section we will be focusing our discussion on the catalytic reaction. So let us discuss a little bit about the catalyst. You should know that what is the role of a catalyst in a reaction, what a catalyst can do and what a catalyst cannot do, right? So let me write a small topic here, you can write down, that is the role of catalyst. Role of catalyst. There are 1 mark questions in GATE exam also, And sometimes the students are confused that catalyst can do this or not, catalyst can do that or not. What is the role of catalyst? The catalyst actually participates in the mechanism of the reactions and provides an alternate, easier path for reaction to occur. Fine, and hence it increases the rate, right? It increases the rate, it increases the speed of the reaction actually. Fine, so what is the role of catalyst basically? You can write down a catalyst do not participate in the reaction. I mean, it is not reacting. A catalyst is not reacting, right? It just enters the reactor and leaves the reactor without undergoing any chemical change. A catalyst do not participate in the reaction. Participate in the reaction. However, it alters the mechanism of the reaction. However, it alters the mechanism of the reaction and hence provides an easier alternate path. Mechanism of the reaction and hence provides an easier alternate path for the reaction to occur. Easier alternate path for the reaction to occur. Okay, for the reaction to occur. Fine. So that is one role of the catalyst. It is not going to participate in the reaction. It will enter the process and leave the process without undergoing any chemical change. However, a catalyst may undergo a physical change, right? Physical change is possible in the catalyst. What is the meaning of physical change? आपने कई बार सुना होगा catalyst has got deactivated. Like आप किसी catalyst को, मैं मान लो अगर catalyst की property में कोई change ही नहीं आता, then तो आप catalyst को कितनी बार भी कितनी देर तक यूज करते रहो, doesn't matter. But it is not happening in reality. In reality, in any industry, in any laboratory, you are using a catalyst, and after some time you see that the activity of catalyst has decreased. Why the activity has decreased? There has been some physical changes. क्या होता है कई बार catalyst के ऊपर कार्बन का डिपॉजिट हो जाता है. Then you have to take out all the catalyst. You have to clean the catalyst, right? And then you have to do some treatments to the catalyst, and then you can use it again. So when the catalyst takes part in when the catalyst is used in a reaction, the physical property of the catalyst may change during the process. However, there is no change in the chemical identity of the catalyst. However, there is no change in the chemical property of the catalyst. So let me write down some more points regarding catalyst, right? So what it is doing actually is, by doing this, what is the advantage that we get? So a catalyst increases the rate of reaction as compared to the uncatalyzed reaction, right? It increases the rate of reaction relative to that of the rate of reaction relative to that of the uncatalyzed reaction, relative to that of the uncatalyzed reaction. Fine. As compared to the uncatalyzed reaction, the catalyzed reaction is going to have uncatalyzed reaction. Yeah, the catalyzed reaction is going to have more rate as compared to uncatalyzed reaction. Fine. So that is the more important role of catalyst. A catalyst sometimes also alters the selectivity in case of a multiple reaction. That is also possible. Let us write that point also. In the presence of a catalyst, like we were using the parallel reaction, आपको पता है parallel reaction में अगर आप catalyst use करो, it is possible that the formation of a particular product will be favored in the presence of a catalyst. So a catalyst can alter the rate of a reaction. It can also alter the selectivity. Fine. So in the case of multiple reactions, in the case of multiple reactions, a catalyst can also favor, case of multiple reactions. Actually, why these points we are writing, they are 1 mark question in itself, right? इस तरह के क्वेश्चन थ्योरेटिकल क्वेश्चंस आते हैं, कई बार आप न्यूमेरिकल की प्रैक्टिस तो अच्छे से कर लेते हो, बट व्हेन थ्योरेटिकल क्वेश्चंस आर आस्क्ड, एंड दिस हेटेरोजेनियस रिएक्शंस टॉपिक इज वन ऑफ दोज जहां से थ्योरेटिकल क्वेश्चन ज़्यादा बनते हैं एंड वो कंफ्यूजिंग होते हैं, एंड दैट इज़ वाई मोस्ट ऑफ द स्टूडेंट आर हैविंग प्रॉब्लम। एंड आपको भी पता होगा, अगर आप दोबारा तैयारी करो या आप पहली बार भी करो, आप किसी से भी पूछोगे बोलेगा कि यार तैयारी तो पूरी आती है, बट वो हेटेरोजेनियस वाला थोड़ा समझ नहीं आया कि उसमें कैसे करना है, कब कौन सा फॉर्मूला लगाना है। तो ये वाला जो पोर्शन है, ये कई बार पढ़ने वालों को, पढ़ाने वालों को ये पोर्शन क्लियर ही नहीं होता कि ये है क्या, ठीक है। सो यू शुड नो व्हाट काइंड ऑफ क्वेश्चंस आर आस्क्ड फ्रॉम दिस हेटेरोजेनियस कैटालिसिस। सो आई एम गोइंग टू टेक अ प्रॉब्लम्स, डोंट वरी, बट बिफोर दैट वी आर जस्ट डिस्कसिंग द रोल ऑफ कैटलिस्ट इन these catalytic reactions. So in the case of multiple reaction, a catalyst can also alter, a catalyst can also alter, a catalyst can also alter the selectivity of the products. Means it can favor one product and cannot favor the other product. Selectivity of the products. It can also alter the selectivity of the products. So that is also the role of the catalyst. Okay? Let us talk about the next role, that is, or what a catalyst cannot do. That is also important to know. A catalyst cannot change. A catalyst cannot change or cannot alter the thermodynamic affinity. A catalyst cannot alter the thermodynamic affinity of a reaction. What is the meaning of this now? Thermodynamic affinity of the reaction. कैसे समझेंगे इसको? Affinity of the reaction. What is the meaning of thermodynamic affinity? You have understood, I think you have gone through the second law of thermodynamics, which says that there are some processes which are spontaneous, there are some processes which are not spontaneous. These kind of things are there in second law. And I told you that mass transfer, reaction engineering, these are also process. और कोई भी process पे second law applicable है. अगर second law कह रहा है, suppose according to the second law, a process is not spontaneous, it is not going to take place. Means a reaction. What is the meaning of affinity? Thermodynamic affinity means whether a reaction between two, ऐसा तो नहीं है ना कि आप कोई भी दो reactant ला के रख दो रिएक्शन हो ही जाएगी. It depends upon it is decided by the thermodynamics. Thermodynamics says that वही process spontaneous होगा, वही process होगा जिसका जो delta G होगा, जो Gibbs free energy change होगा, वो negative होगा. इस तरह की चीजें आप पढ़ते हो thermodynamics. I'm not going to discuss that here, but you should relate the subjects. कोई भी प्रोसेस ले लो, whether it is a reaction. I also told you about the equilibrium conversion, that up to what you can go in a reaction, that is limited by thermodynamics. So thermodynamics is going to control the heat transfer, the mass transfer, the reaction. These are all processes. ये thermodynamics से ही control होगा. तो thermodynamics is also going to decide whether a change can occur or not, whether a process is going to occur or not. That we deal in the second law of thermodynamics. तो एक reaction होगी या नहीं होगी, that is dependent, that is decided by the thermodynamics, and that is called thermodynamic affinity. Now suppose according to thermodynamics, the reaction between A and B is not possible. Suppose A and B are two reactants, and the thermodynamics says that there could be no reaction between these two. That is called thermodynamic affinity. Now you are saying, no sir, I have a catalyst, I have a special catalyst, I am going to use that catalyst and then the reaction will occur. Forget thermodynamics. It's not like that. You can't leave thermodynamics, उसको साथ में लेके चलना होगा. If thermodynamics says कि ये reaction नहीं हो सकती, then a catalyst cannot alter the thermodynamic affinity of the reaction. इसका ये मतलब है कि अगर कोई reaction नहीं होगी तो उसमें कितना भी catalyst डाल लो, वो reaction नहीं होगी. होना ना होना is not going to decided by the thermodynamics. ये किसके हाथ में है? ये it is not going to decided by the catalyst whether a reaction will occur or not occur. That has to be decided by the thermodynamics. वो process होगा कि नहीं होगा, ये thermodynamics decide करेगी. But suppose if process is possible, then the catalyst can increase the rate of that process. That is the role of the catalyst. Okay. Now means a catalyst cannot change the thermodynamic affinity, means it is going to it is affecting the rate but not the tendency of the reaction to occur. That is an important line. Means you can write it is affecting the rate, means it is going to increase. Sometimes a catalyst can also decrease the rate. That are special kind of catalyst. Okay, so let us not talk about that. It is affecting the rate but not the tendency of reaction to occur, but not the tendency of the reaction to occur, but not the tendency of the reaction to occur. That is one important point, that what of the reaction to occur, that what a catalyst can do and what a catalyst cannot do. There are many other points regarding the catalyst. Let us write. These are the gate questions in itself. You can write a catalyst will not change. A catalyst will not change, will not affect, you can say, affect or alter. A catalyst is not going to alter the following. What a catalyst is not going to alter? The first one is the free energy change. Delta G of a reaction is not altered by a catalyst. Just remember these points. These points are important. Free energy change means the delta G cannot be changed by a catalyst. What else? Equilibrium constant. I think I also told you that equilibrium constant is only affected by temperature. So I mean Kc is not changed by a catalyst. One more thing where the students are confused, that is the equilibrium conversion. Equilibrium conversion is also not affected by the catalyst. Equilibrium conversion. Equilibrium conversion. I told you that what are the factors which decide the equilibrium conversion, means XAE is also not affected by the catalyst. Yeah, it is possible that the time required to reach this conversion is going to affect it, means the rate. Again, rate के बारे में बात कर चुके हैं. The time required to reach this conversion is going to be affected by the catalyst, but the value कहाँ तक जाओगे, that maximum possible value is not going to be affected, is not going to be changed by the catalyst. Okay. Sixth point. Okay, one more thing let me add here, that is enthalpy change of a reaction. Enthalpy change is not going to affected by the, these are the things which are not affected by the catalyst. The fifth point it was. Okay. Okay, you can also write a catalyst helps. I think all these points are going to make all your concepts, all your doubts regarding what a catalyst can do, what a catalyst cannot do, very much clear, right? So that is important to have clarity of the concepts. A catalyst decreases or reduces the time required to achieve the conversion. The time required to achieve XAE means you know that you can go up to XAE. That is your limit. Now the catalyst is not going to change the increase. The catalyst is not going to increase or decrease that limit. Yeah. So you can achieve this equilibrium conversion in a smaller amount of time. You can write that both forward and backward reactions are accelerated to the same extent. Both forward and backward reactions, so that you achieve the value of equilibrium conversion in a smaller time. Both forward and backward reactions are accelerated to the same extent by the catalyst, right? So don't think that only forward will be accelerated or only backward will be accelerated to the same extent. Accelerated to the same extent, right? That is one more important point regarding the catalyst. So these points, all points I have already discussed, that what a catalyst now can do and what a catalyst cannot do, that you must know, right? So these were some points regarding the work of a catalyst. I hope you also know there is a graph regarding the work of a catalyst. This graph you have studied in class 11, 12 also, but still let me make this graph, which shows that the catalyst basically decreases the forward and backward activation energy and hence provides the easier path for reaction to occur. So this is the energy and this is called reaction coordinate. Actually means reaction coordinate means how far the reaction has reached. So So reaction coordinates. You can also say the, okay, now reaction coordinate limit is fine. Okay. So suppose A plus B is the reactant, and you know that this is the activation energy of the forward, and then suppose this is the product, C plus D. Fine. What do we have some nomenclature here. This thing is called transition state, and this gap is called forward activation energy. Forward activation energy of uncatalyzed reaction. Similarly, this is called backward activation energy of uncatalyzed reaction. Fine. And one more thing, that this height is called the threshold energy for the reaction. This is called the threshold. No need to go into detail of this. Threshold energy. Okay, now what happens in the presence of a catalyst? The catalyst is going to decrease both forward as well as backward activation energies like this. Suppose in the presence of a catalyst, this is the path followed by the catalyst. The catalyst is going to decrease both forward as well as backward activation energy. You can see that in presence of the catalyst, you have this path, fine, and in this case, this is the backward activation energy. The red one is in the presence of catalyst, right? And this is the forward activation energy. So the catalyst is going to decrease both the activation energy, fine, to the same extent also. So you can see that an easier path for the reaction to occur is provided by the catalyst. I hope you also know the formula for enthalpy change of the reaction in terms of activation energy, that is given by EAF minus EAB. Fine, and it shows that EF is more, EAB is less, so delta H will be positive. It means that this diagram is for endothermic reaction. This was all about the things that we are going to discuss in this chapter and the role of a catalyst in a catalytic reaction. Now one more very important point let me discuss here. So let me erase this part so that I can explain that concept. Now the reaction or the steps which are occurring in this heterogeneous reactions, they may be in series or they may be in parallel. So how to deal with these multiple steps taking place in series or taking place in parallel? These steps has to be dealt with different methods. So we should know that how to deal when reactions are taking place in series and how to deal when reactions are taking place in parallel. Fine. So I'll leave this portion as it is and let me use this space. So by now we know that what are the methods of expressing the rate here, and we are going to deal with the catalytic portion only and not the non-catalytic portion. We also know the basics of working of a catalyst. Okay, now you can write the next point from here, that reactions or let me write steps. Reactions, or not only reaction, it can be any step. So let me write steps here. Fine, steps in series. Steps in series. Why I am discussing this? It will be clear after some time when we are going to take up some problems. When steps takes place in series, why I am calling it step? Why not reactions? Because in case of heterogeneous, there are a number of steps. Actually, we are going to discuss those steps. It can be absorption, it can be external mass transfer, it can be adsorption, desorption, and one of the step is reaction also. Fine. So that is why I am not writing reactions in series. It's not like every step is a chemical reaction. It can be adsorption, it can be desorption, it can be surface reaction, it can be external mass transfer, it can be internal mass transfer, can be anything. So that's why I'm writing steps in series. Now you have to understand this point very carefully. Suppose steps are taking place in series. What does it mean, steps in series? जब भी आप series में steps की बात करते हो, it means that one step cannot, the next step cannot occur unless the previous step has occurred. Okay, it means when steps are taking place in series, फर्स्ट दिस स्टेप हैज टू बी डन, देयर आफ्टर दिस स्टेप विल बी कंप्लीटेड, और उसके बाद अगला वाला स्टेप होगा. दिस इज द मीनिंग ऑफ स्टेप इन सीरीज. इट इज नॉट पॉसिबल दैट बिफोर गोइंग थ्रू द फर्स्ट स्टेप you can directly go to the second step. It's not possible like that. Suppose you can imagine that you must have आप लोग सारे लोग कॉलेज में हैं या अभी पास आउट हो चुके हो. Thus imagine the scene in your college. When you enter your college, where is the first point when you enter in the campus of your college? Probably that is the main gate of your college. That is the first step when you are going to enter the college. After that entrance, then you must go. I think all of you are going to your respective department. Suppose after entering your college through the main gate, you are now going to the department of chemical engineering, and that chemical engineering department has wider gate. It is not as wide as your main gate of the campus, but it is a wider gate. After entering the department, you go to your respective laboratories or you go to your respective classrooms. Now you know that the classrooms are having a smaller gates like that. Okay, so this is an example of steps taking place in series. आप बिना main gate से enter किए हुए you cannot go into the department gate. Without entering the department, you cannot go into your classroom. I'm not talking about the other methods जो आप सोच रहे हो, वैसा कुछ नहीं. Just सिंपल बातें कर रहे हैं, ठीक है. सिंपल बातें मतलब आपको और कोई ऑप्शन नहीं है, आप कॉलेज की बाउंड्री कूद के अंदर नहीं जा सकते हैं ना. आई एम टॉकिंग अबाउट द बेसिक जो आप यूज़ करते हो डेली, आप जो कॉलेज में जिस तरह से एंटर करते हो, राइट. तो पहले आप मेन गेट में एंटर करोगे, देन आप डिपार्टमेंट गेट से एंटर करोगे, एंड देन यू हैव टू एंटर द क्लासरूम गेट. दिस इज द एग्जाम्पल ऑफ स्टेप्स टेकिंग प्लेस इन सीरीज. फाइन. Okay, so I hope you understand when we call that steps are taking place in series, when the second step cannot occur until the first step has occurred. So this is called the steps taking place in series. Fine. Now when the steps are taking place in series, suppose I'll give you an example. Suppose you guys are entering in groups in your college. Suppose जो main gate is allowing 50 students to enter in 1 minute. Are you getting my point? The main gate of your university campus or college campus is allowing 50 students to enter in 1 minute. Fine. But your department gate is allowing only 20 students to enter per minute. Why? Because the space is less in the department gate. And similarly, your classroom door, the main door of your classroom, is allowing only 10 students to enter per minute. Now what is going to happen? Let us understand the scenario here. So this is your university gate. Fine. This is your department gate. Okay, this is your department gate, and then this is your classroom gate. These are the steps taking place in series. I hope you understand this. You have to enter from here, then you have to enter from here, then you have to enter from here. Don't ask कि सर हमेशा ऐसा ही होगा क्या, that the third step is having less space. We are just taking one example to understand the steps taking place in series. Now what happens? That if you take 1 minute as the basis, my basis is 1 minute. If you take 1 minute as the basis, then this gate is allowing 50 students to enter in 1 minute. This gate, the gate of your department, is allowing only 20 students to enter in 1 minute, while the classroom gate, the main door of your classroom, is only allowing 10 students to enter per minute. What is going to happen? Tell me. Suppose all of the 50 students are chemical engineering students. They are going to enter to the chemical department only, and all of them are in the same batch, so they want to go into the same classroom. What is going to happen? This is the capacity of the door, that it can handle a maximum of the students in 1 minute. What is going to happen? And also suppose that continuously the students are coming. ऐसा आप ऐसा नहीं बोलना कि सर 50 यहाँ से चले गए, बाद में अगले मिनट में यहाँ से चले जाएंगे. It's not like that. Just assume that continuously the students are coming from the sides and continuously they are leaving. It's a continuous process, right? What is going to happen? Here you will say that, sir, if this is the scenario, if 50 students in 1 minute are entering this gate, and the second gate is only allowing 20 students to cross, then what is going to happen? Every minute 30 students accumulate. That is the meaning of accumulation. Accumulate at this gate. At this gate. I hope this is clear. Because यहाँ से continuously student आए जा रहे. See, in 1 minute 50 students are entering here. They are crossing the gate, but this is only allowing 20 students to cross. So in 1 minute 30 students यहाँ पे इकट्ठे हो जाएंगे कि मुझे भी जाने दो. We want to enter the department. But this gate is only allowing 20 students. Fine. Similarly, in the next minute 50 students are going to cross this gate. Out of those 50, again 20 can go into this gate, and again 30 students are going to accumulate it. So in 2 minutes there will be 60 students accumulated here. In 3 minutes there will be 90 students accumulated here, like that. So what is going to happen? Every minute 30 students can accumulate at this gate. यहाँ पे धीरे धीरे भीड़ बढ़ती जाएगी. Okay. One more point here. Now out of those 20 students which are crossing the department gate, only 10 is allowed to go into the classroom. I mean, because of the limited capacity of the gate. So what is going to happen? Every minute, let us take a different number here so that 10 and 10 is not going to cause any confusion. Let's say 15. 15 students capacity is there in the classroom door. So every minute what is going to happen? Every minute 5 students, every minute 5 students accumulate at this gate. I think you are getting the point what I want to convey here, what is happening here at this gate. Means 50 students are entering from the first gate, 20 are allowed to cross, so 30 are standing at the door. Out of that 15 are allowed to cross, so 5 are standing at the door. Again next cycle comes, again 50 students are coming, 30 more are accumulated here, only 20 are passed, and again 5 more are accumulated here and only 20. What is going to happen? Each and every cycle, when more and more, suppose we have infinite number of students, there is no limitation to the number of students, you have infinite number of students. Okay, so the students are continuously entering, and at each and every minute accumulation is taking place on these two doors. Fine. So what do you suggest? I mean, what can you say about this condition? This is the unsteady state condition. Fine. This is the unsteady state condition. You must have experienced, those who drive vehicle either bike or four-wheeler, agar aap drive karo, you must have experienced this condition. Suppose you are driving on a 6-lane highway. You are driving from Delhi to Chandigarh. The highway is 3-lane on this side and 3-lane on that side, as far as I know. So if you are driving from Delhi to Chandigarh, there is 3-lane highway on both sides. You are driving at a speed of 80 kilometers per hour on your bike, so you are enjoying the ride. But what happens then, that when you are going to cross Panipat, a lot of constructions of flyover is going on. तो जब आप दिल्ली से चंडीगढ़ जा रहे हो, there is a lot of constructions going on. First of all, there is 6-lane highway. You are moving freely, right, at 80 kilometers per hour. But after some time, some construction is going on, due to which there is a diversion. And the diversion road is not a 3-lane road. Fine, the diversion road is not a 3-lane road. So suppose on the 3-lane highway, in 1 minute, 10 vehicles can pass, I mean side by side, 10 vehicles can pass on the 3-lane highway. But when there is a diversion, there is a very small road there. And that road is only allowing 2 vehicles to pass. What is going to happen? That every minute, 8 vehicles will be accumulated, or at that point where the highway is now diverted, right? So every minute 8 vehicles is going to be accumulated. ये आपने देखा होगा, right? जहाँ भी चौड़ी road, जहाँ भी high 4-lane road or 3-lane road is now becoming 1-lane road, or now it is having the thickness of the road, the width of the road, not the thickness, I should say width, the width of the road decreases. जहाँ भी ऐसा होगा, there has to be accumulation, because from the back side more vehicles are coming, more students are coming from the back door, from the main university door. However, this door is only allowing 20. Fine. So I hope you understand that in series reactions or in series step, if this rate and this rate and this rate If all these rates are different, then what is going to happen? Unsteady state condition is going to happen. Now the next question is, how to achieve steady state in the above scenario? How to achieve steady state in the above scenario? How to achieve steady state in above scenario? Kaise? Suppose I am asking you, okay, that you are the university administration, you are into the university administration, and I'm asking you that how to solve this accumulation problem. You are going to say that, sir, make every rate equal. Yes, definitely you can make every rate equal, but please note that we can't change the sizes of the door. Then how you are going to make every rate equal? So if you want to have steady state, there should not be any accumulation. We know that steady state means there should be no accumulation. फिर भी मैंने आपको कहा कि बताओ अब इसमें स्टडी स्टेट कैसे आएगा? हाउ यू कैन अवॉइड द एक्यूमुलेशन? यू सेड कि सर ओके, एंड वन लिमिटेशन, यू आर नॉट गोइंग टू चेंज द साइज ऑफ द गेट्स. फाइन, दिस इज द यूनिवर्सिटी गेट. फाइन, दिस इज द यूनिवर्सिटी गेट. दिस इज द this is the department gate, right? This is the department gate. This was the university gate and this was the department gate. Okay, yeah, this was the department gate and this is the classroom gate. Now the sizes of the gates are same. My question is, how you can achieve steady state in this series step? क्या बताओगे? I think all of you will have the same answer, that sir, do one thing, tell the students that only 10 students should enter from this gate and 10 students should enter from this gate, and definitely, okay, I have changed this number, okay, excuse me for this, only 15 students should enter from this gate. 15 students should enter from this gate, and definitely this gate is allowing 50. Can I have steady state in this case? What is your answer? The answer is yes, definitely you can have studies. There will be no accumulation. So what is your suggestion? The suggestion is, sir, please tell the students that don't come in 50s, come in 15, 15, 15. And then every gate will be allowing you to cross in 1 minute, and then there will be no accumulation. So what does it mean? In the case of reaction engineering, आपको इसको कैसे समझना है? It means at steady state, what happens? At steady state, the rate of first step, it can be a reaction, it cannot be a reaction, it can be a physical process also. The rate of the second step and the rate of the third step, all are equal. Getting my point? To have steady state, the rate of the first step, the rate of the second step, the rate of the, क्योंकि अगर ऐसा नहीं होगा, see, there will be accumulation. They have to be equal. They are equal तो sign लगा ही दिया, there is no need to write equal, and that is called the over. If I ask you what is the overall rate here, you are the teacher, let us become teacher, you are the teacher for some time. Suppose you are the teacher, you are standing here. What is the overall rate you are observing in this case? You have steady state. For steady state, each gate is allowing only 15 students. See, the capacity of this is 50, but the capacity of this is 20. But I am only allowing 15 students, and then I can have steady state. So what is the rate you are going to observe? आपको हर मिनट में कितने बच्चे आते हुए दिखेंगे? Only 15. So it means all the rates are going to be same. That will be equal to the overall rate, and it will also be equal to the rate of the slowest step. That is an important point. That will also be equal to the rate of slowest step. Because we know that this is the deciding factor. This is the deciding factor. आपने पढ़ा होगा कि then when steps are taking place in series, one of the step is the slowest step because it is having the maximum resistance. You can see that this is having the maximum resistance. Fine, this is having the maximum resistance because it is allowing only 15 students, and accordingly I have to send only 15 students from each and every gate, so that all the rates are equal. That is equal to overall rate, and that is equal to the slowest step. Getting my point? अब यहाँ कोई accumulation नहीं होगा. We are having steady state. It means whenever steps are taking place in series, You want to have steady state, then the all rates must be equal, then only you can have steady state, and the rate should be equal to the rate of the slowest step. That was one point of view. Fine. Now you are working in the university administration. Now a student came to complain कि sir, okay fine, now there is no accumulation at any gate, we are happy, but we want you to increase the overall rate. Means the student is asking you कि sir, do one thing. What is the rate you are observing right now? 15. The student has, the student union ने आपको एक मेल लिखी और उसमें लिखा कि sir please increase the overall rate to 30 or to 50 also. Suppose now you want to increase the overall rate. Now what is the scenario? On the student's request, we want to increase the overall rate. We want to increase the overall rate. देखते जाना, समझते जाना, ठीक है ना? आपको समझ आएगा कि मैं क्यों बता रहा हूँ. थोड़ा बहुत शायद समझ आने लगा हो. Then we want to increase the overall rate. Now what is the idea? You want to increase the overall rate. What was the overall rate you were observing here? 15, because everyone is 15, 15, 15, 15, 15. Overall rate to, let's say, 25. You want 25 students. You want to observe 25 students per minute. What is your suggestion? What is your suggestion? Let me give you one more example. Suppose you guys, all of your batch is going to plan a trip. You are going to plan a trip in the mountains. Now you made a group. The group consisted of both, you can say both boys, girls, and then you guys are planning to make a trip. And suppose the group is having total of 10 members, right? So some of you suggested that we are going to travel by train. Some of you suggested that we'll prefer a bus, right? Then there is always a planner in the group. The group planner decided, okay, don't worry, let us go by the bus. And most of you agreed. But there is always one guy or one girl in the group, or two guys or two girls or one girl in the group, right? There is always a guy in the group who is not happy with the policy, with this travel choices of your entire group. है ना? There is always a guy, है ना, who is not happy. वो बोलेगा कि नहीं, बस से क्यों जाना? Let us do cab. Let us get a cab here. Let us get a Zoom car. Let us hire cabs. Let us take Uber. The guy who is having the most of the resistance, वो नहीं मानेगा आपकी कोई बात. वो बोलेगा नहीं, I am not going to travel by train. I am not going to travel by bus. I am going to travel by the private taxi, the private cabs. Now, based on that guy, that guy is having the highest resistance. That guy is having the highest resistance. ठीक है? वो किसी भी बात को मानने के लिए तैयार नहीं होता, तो आप क्या करोगे? You don't have option to fire that guy. आपको उसको ग्रुप से निकालने का ऑप्शन नहीं है. What you are going to do? You are going to convince him कि अगर ये बंदा मान गया तो हमारी ट्रिप हो जाएगी. ठीक है? You are going to convince him. He is the deciding factor there. In real life, the person who is having most of the resistance is the deciding factor. The person who is having most of the resistance. Suppose आपको बाइक लेनी है, आपको बाइक लेने के लिए पैसे चाहिए. You want money, है ना, to purchase a bike. Fine. But in your family, who is the deciding factor? Generally, your dad, your mom is the deciding factor because they are having most of the resistance. पैसा तो आपके पास आ गया. Suppose आपके big brother ने, आपके बड़े भाई ने आपको पैसा दे दिया. Fine. But who is having the most of the resistance in the family? Your dad, your mom. So you are going to take permissions from him कि अगर ये मान गए, then definitely I'll purchase a bike today only. Okay. So that is the thing. आपको अगर चीज़ों को change करना है, if you want to change the things, आपको उस बंदे को मनाना पड़ेगा. You have to convince that person who is having the highest resistance. This happens in real world also. The same thing is happening here. Now, what is the idea? We want to increase the overall rate to 25. Fine. Now, some of you suggested that, sir, do one thing. If you want to increase the overall rate to 25, then do one thing. Increase, or let's take a different number. Just I wanted to convey one thing. So let me change this value. Can I change this to 20? Okay, still it is fine. I want to increase the overall rate by 20. What should I do? Some of you suggested कि sir एक काम करो. If you want to increase the overall rate to 20, then do one thing. Make the university gate bigger than before. Will it work? What do you think? I want to increase the overall rate to 20, And some of you suggested that, sir, do one thing, just do some renovation work and make the university gate bigger than before. What do you think? Will it work? The answer is no, because from here already 50 students were able to pass. You are already making it bigger. But what about the smallest gate? The smallest gate will only allow 20 students, 15 students. The smallest gate is only allowed 15 students to pass. Then can you increase the overall rate? Of course not. You can't do that. It means if you want to increase the overall rate, you have to change that step which is having highest resistance. Very, very important point. We want to increase the overall rate to 20 in series. So what is the result? What is the see what you are going to do? From this gate, can 20 student pass? Yes, of course, because it was having a maximum capacity of 50 students. So definitely from this gate 20 students can also pass. So there is no problem with this gate. Who is having the highest resistance? The last one is having the highest resistance. If you are not changing the last step, if you are not changing the rate of the last step, then definitely this gate has to be made bigger than before, so that it can allow 20 students, 20 students, 20 students, and then again you have steady state. What you are going to observe? You are going to observe 20 students. You have, is it steady state? Yes, because all of them are same. Have you increased the overall rate? Yes. So what is the idea here? The idea is, it's same like that. मान लो traffic jam लग रहा है. There's a traffic jam because 6-lane highway or 4-lane highway is now converted into a single lane highway. There's a traffic jam. And you are the advisor of the government. You are saying that, sir, एक काम करिए, जो 4-lane highway है इसको 8-lane highway बना दो, then the traffic jam will be reduced. होगा क्या ऐसा? कुछ नहीं होगा. If you want to reduce the traffic jam due to the 4-lane highway was getting converted into 1-lane highway, and if you want to reduce the traffic jams, assuming that the same number of vehicles are there, then your advice should be, sir, please do something so that the 1-lane highway will be converted into 3-lane or 4-lane highway. Means if you want to change the overall rate, you have to change the rate of the smallest step. The slowest step, slowest step, or the step which is having more resistance. That is the idea I wanted to give you. That in series steps, if we want, this is a very important line. You'll understand the importance of this line when I'm going to take problems. In series steps, if we want to increase the overall rate, increase or decrease, anything you can do, increase or decrease. See, आप जो controlling है ना, controlling, अगर controlling को change कर दो, who is controlling? As I told you in real life also, who is controlling? The one who is having the highest resistance. They are always controlling. Fine. So who is controlling here? This step is controlling. If you are changing this step, then you can see that the overall rate is going to change. But suppose if you are changing this step, then nothing is going to happen. Okay, so in series steps, if you want to increase or decrease the overall rate, then that step should be altered. That step altered means उस step में आप कुछ increase or decrease कुछ भी कर सकते हो. Then that step should be altered. That step should be altered, which is having highest resistance, और जिस step का highest resistance होगा, that step is also called the slowest step, and that step is also called the rate controlling step. Fine, that step is also called the rate control. वही control कर रहा है, everything is controlled by him or her. Okay, rate controlling step. Right? Okay, so in series steps, if you want to increase or decrease the overall rate, then that step should be altered. This is altered, seems like H. That step should be altered, which is having highest resistance, or which is the slowest step, or which is the controlling step. Got my point? Now I'm going to write this equation in reverse manner. What is reverse manner? Suppose there are 3 steps. You don't know which one is controlling. You are changing this step and you are observing that the overall rate is not getting changed. You are changing this step, you are observing that the overall rate is not getting changed. You are changing this step, now you have observed that the overall rate has also changed. What does it mean? It means that if by changing a particular step in series steps, the overall rate is getting affected, it means that particular step is the slowest, rate controlling has the highest resistance. Just the reverse of this. Write down. In series steps, comma, if by changing or altering, increasing or decreasing, anything can be there, if by changing the rate of a particular step, if by changing the rate of a particular step, the overall rate gets affected. In series steps, if by changing the rate of a particular step, the overall rate gets affected. ये बहुत काम की चीज बता रहा हूं. The overall rate gets affected, then the overall rate gets affected in series steps. If by changing the rate of a particular step, the overall rate gets affected, just the reverse of this. It means that particular step is the rate controlling step. It means that particular step is the rate controlling step. That step controls the entire process. Rate controlling step. This is very, very important for steps taking place in series. Suppose if the steps are taking place in parallel, then is it always required that both the steps should have the same rate? No, they can have different rates. If the steps are taking place in parallel, then the overall rate is given by the addition of those two rates. Fine. But if the steps are taking place in series, don't say that, sir, the overall rate is equal to this plus this plus this. This overall rate is not 45. It is 15 only. Overall rate is equal to the rate of individual steps at steady state. Is case ki baat, what is the overall rate here? You are going to observe 15 here. However, there will be accumulation at each and every gate. You want steady state, then each and every rate should be equal, and it should be equal to the slowest step also. Fine, and that is also equal to the overall rate. And this idea which I am giving you here, very, very, very important. Most of the questions जो heterogeneous में बच्चों से solve नहीं होते हैं ना, those questions will be solved by using these two definitions. फाइन, क्योंकि ज़्यादातर बच्चे ले आते हैं कि सर ये तो समझ ही नहीं आ रहा, पूछ क्या रहा है, इसलिए माइंड में उनके एक मेंटालिटी हो जाती है दैट हेटेरोजेनियस के लिए पता नहीं कौन सा फॉर्मूला लगता है. कोई फॉर्मूला नहीं लगता, बस ये कॉन्सेप्ट लगता है. For solving many, you will find that there are many questions from heterogeneous reaction which are written in tabular form. So how to solve all those questions based on these concepts? We'll take up problems all at once. Let us first discuss the theory, because in this section theoretical discussion is more as compared to numerical discussion, right? Now I was talking about the steps taking place in parallel. When steps are taking place in parallel, then the overall rate is always given by the addition of the rate of individual branches. Fine, वहाँ पे equal होना, it's not necessary that the rates of the two steps taking place in parallel is equal. It's nothing, there's nothing like this. Okay, I hope this is more important for you, the steps in series. That's why I'm not writing the steps in parallel. So I hope this idea is clear to you. Now after this, we can go to the discussion of the catalyst, the efficiency, the Thiele modulus and all that. But before going into the discussion of those things, अगर ये क्लियर नहीं होगा, then you will be able to solve only few numerical problems of heterogeneous catalysis. Rest of the problems को solve करने के लिए आप थोड़ा सोच नहीं पाओगे, है ना, thinking develop नहीं हो पाएगी. Okay, so I hope the idea that I wanted to convey here is clear.